This video is for lesson 15-4 about rectangles, rhombuses, and squares. Learning goals are to develop some properties of rectangles, rhombuses, and squares. A rectangle is a parallelogram with four right angles. So a parallelogram tells us the opposite sides are parallel, and four right angles tells us that all four corners are 90-degree angles. So in question 1, we're given a drawing of a rectangle called RECT. Notice that the diagonals of that rectangle are drawn, and that creates some congruent triangles. From that, we can create a theorem. Number 2, the diagonals of a rectangle are blank. What's true about the diagonals of that rectangle? We could say that they are congruent. That's one theorem or one property of rectangles that we can use to solve problems. So this right here is something that should go in the notes that you need to know, that the diagonals of a rectangle are congruent. There are other theorems that we could create about rectangles. For example, we could conclude that the opposite sides of rectangles are congruent to each other. And we could write that out in words, and that would be a theorem. Or we could conclude that the diagonals of a rectangle bisect each other. For example, in the rectangle that's shown on the screen, that is equal to that, and that is equal to that. So this dot right here is the midpoint of both diagonals. These kinds of theorems allow us to solve problems involving rectangles. Here's an example problem, number 6. Given quadrilateral, TGIF is a rectangle. So we're told that this is a rectangle. So every theorem that we know about rectangles could be used to solve problems about this. Question A, if Tx equals 13, so the distance from T to X is 13, let's write that on there, then how long is Ti and how long is FG? So Ti is the entire diagonal, and we know that this much is 13. So we could conclude the entire diagonal is 26. And what about FG? That's the other diagonal. It's also 26 because of our theorem that the diagonals of a rectangle are congruent. Now question B, solve for x if Tx equals 4x plus 4. So let's take the same drawing, remove the 13, and relabel Tx as 4x plus 4. We're also told in question B that Fx is 7x minus 23. Well, what's the connection between that segment and that segment? They are congruent to each other. And that's how we get our equation. The 7x minus 23 is equal to the 4x plus 4. Solve the equation for x. So subtract 4x from both sides, that makes 3x. Add 23 to both sides, and that is equal to 27. And 3 times 9 is 27, so x is equal to 9, and that's question B. Here are some check your understanding questions. Number 8, what do rectangles, trapezoids, and kites have in common, and how are they different? And then number 9, tell whether each of the following statements is true or false. So this is 4 separate questions. You're going to answer each of them true or false. Here are the answers. In number 8, all 3 of these things are quadrilaterals. That's what they have in common. Now to say how they're different, we could focus our attention on each one and focus on the properties of those shapes. For example, in a rectangle, all 4 angles are 90-degree angles. That's not the case in a trapezoid or a kite. For a trapezoid, there is at least one pair of parallel sides, but that's not the case for a kite, and so on. Then in question 9, these true-false questions, you see the answers in blue. All rectangles are parallelograms. That is true. All rectangles do have 2 pairs of parallel sides, and that's what a parallelogram is. Now, some rectangles are trapezoids. That's false. All parallelograms are rectangles. That's false because there are parallelograms that are not rectangles. Consider this drawing here in blue ink. That is a parallelogram, but it's not a rectangle. And then D, all rectangles are quadrilaterals. This is saying all rectangles have 4 sides. That's certainly true. Okay, our next vocabulary word is the word rhombus. A rhombus is a parallelogram with 4 congruent sides. So we had the vocab word rectangle, a parallelogram with 4 90-degree angles. And here's the word rhombus, a parallelogram with 4 equal sides. Here is a drawing of a rhombus. This is rhombus EFGH. All 4 of these sides are congruent. Notice the diagonals of this rhombus are drawn, and they cross each other at what appears to be a 90-degree angle. We could create some theorems about this rhombus. One thing we could say is that the diagonals of the rhombus are perpendicular to each other. Another thing we notice is that this is equal to this, and that this length is equal to this length. We could say that each diagonal of a rhombus bisects the other diagonal. These properties or theorems about a rhombus allow us to answer questions about rhombuses. Here's an example, number 13. Given quadrilateral UTAH is a rhombus, so we're told that this is a rhombus. Use our properties and theorems of a rhombus to answer this question. Solve for x if the measure of angle UPT is 4x plus 18. So let's find that. U to P to T. Right in here, this is 4x plus 18. Well, this is a rhombus. So this angle here in the center where the diagonals cross each other is a 90-degree angle. And so that creates our equation. 4x plus 18 is equal to 90. Subtract 18 from both sides, we get 4x equals 72, and then divide by 4. 72 divided by 4 is 18, and we have solved for x. Question B, solve for x and y if we're given this information. So let's erase the labeling that we had done to answer question A and redo that labeling in order to do question B. UT is 5x plus 4. That's this side up here, 5x plus 4. TA is 2x plus y. So this side is 2x plus y. HA, the bottom down here, is 2y minus 8. And then UH is 24. So this is 24. Now, because this is a rhombus, all 4 of these sides are equal to each other. And so the 5x plus 4 is equal to the 24. Subtract 4 from both sides, we get 5x equals 20, and then 5 times 4 equals 20, so x equals 4. Notice that this bottom side here, the 2y minus 8, that's also equal to that side, 24. And so 2y is equal to 32, therefore y is equal to 16. We figured out x and y by making equations, and we made the equations using our properties of rhombuses, specifically that all 4 sides are equal to each other. Now the next vocabulary word in the lesson is the word square. Here's the definition of square. A square is a parallelogram with 4 right angles and 4 congruent sides. In a sense, this is saying that a square is a rectangle, and at the same time, a square is a rhombus. So here's a drawing of a square. Notice the diagonals are drawn so that we can try to discover some theorems. We could come up with a lot of them. The opposite sides of a square are parallel. The opposite sides of a square are congruent. The diagonals of a square bisect each other. The diagonals of a square are perpendicular to each other. All kinds of properties that we could create for a square. Here are some check your understanding questions, so I'll pause the video for you to answer these. In question 18, these are all separate questions to answer true or false. And here are the answers. Number 18, all squares are rectangles. That's true. To be a rectangle, there are 4 90-degree angles. So do all squares have 4 90-degree angles? Yes. Question B, all rhombuses are squares. That's false. There can be shapes that have 4 equal sides, but they're not a square because they don't have the 4 90-degree angles. For instance, this drawing here in blue ink. This is a rhombus, but it is not a square. Question C, all squares are parallelograms. This is saying all squares have opposite sides parallel. That's true. Then, some squares are kites. That one's false. Remember, a kite has the 2 distinct pairs of congruent sides. Those are congruent, and then these longer ones are congruent, but it's not where all four sides are congruent. And then question E, no rhombuses are trapezoids. That's true. Number 19, what do all rectangles, squares, and rhombuses have in common? One thing you could say is they are all parallelograms. All of these shapes have the two pairs of parallel sides. So in this lesson, we had some vocabulary word, rectangles, rhombuses, and squares, and we used properties of these three different shapes in order to answer some questions about them. These questions tended to involve the length of sides, or the measure of angles, or perhaps involve the diagonals of the shapes.